you'll find that with graph theory and network, if you do not remember the definitions, you will be lost in the test or the exam, all right? You must remember the definition. That's the most important thing for graph theory. A lot of it is just basically understand how to draw the graph, which is network, and it's actually really useful. All right? Now, so for today, you should understand what a graph and identify the key element of the graph, which is vertex or vertices, plural, edge or edges, face or faces, and you should be able to explain the key features of the graph. That is quite important. You need to know what are multiple edges, you need to know what are loop, what is actually an isolated vertex, digraph, and so on and so forth. Now, you should be able to determine the degree of a vertex as well, and be able to identify situation which can be represented by a graph and interpret the connection. All right? So, we're going to start, and I've given you a sheet with all the terms that you need to know. All right? Those are important. You need to know all the terms. All right. Now, where are graph theory used? It's not this sort of graph that we are looking at. All right? We are actually looking at networks. Not asking you to plot graph like this, but I'm asking you to think about how we could represent network. How do you describe the relationship between lines and points? All right? So it is useful in situations like postal delivery and rubbish collection routes. How to minimize the cost of petrol and maximize or minimize the time. So you could actually deliver the your parcel or your letters efficiently. Think about the house wiring system. If you've got a network sort out, you know, or school, minimizing the cost. Vehicle navigation system, things like computer science, network of communications, data organization, and so on and so forth. All right. So it's actually used quite a lot, graph theory. Now, looking at something like this, this is our Perth Metro railway system. This is sort of like quite a simple, straightforward network. All right, you know that there are 1, 2, 3, 4, 5 legs that you can go to, and you can travel from one to the other based on that. All right, of course, I haven't included the airport link here. This was quite old. However, if you think about, who has been to London?
London.
Yeah. And have you done the railway, the network? It's like a maze. Yeah, you got to be London Underground. You've got to be really.
So you get shit.
I don't know. I've been there a few times. I still get a little bit lost with the underground system in London. I don't use it day to day, but it's something like this that can be represented by a network. All right, this is actually a network of the London Underground. See how complicated it can be. All right. So now let's start off with definition of a graph. A graph is a diagram which consists of a set of points called vertices or vertex singular that are joined by a set of lines called edges or arcs. The separate areas are called faces or regions. So you need to know your definition. All right. So general definition of graph is just points connected by vertices. Points called vertices connected by edges, and all the separate areas are called faces. All right, this is the basic one. I have never seen a question tested on this, but you do need to know the definition. All right. So let's have a look. These 4 points are the vertices of a graph. All right? The green lines, they are the edges or arcs. Normally, I will use the word edges. And then there's 4 vertices, 5 edges, and the rest are called faces. If you look at this graph here, within the 3 lines, that's considered one face. Within that curved line and the straight line is another one. Anything outside, that's considered one face. All right? So you can see that everything that's outside, that's all connected, that's considered as one face. So you've got 3 faces there, you've got 3 faces there, you've got 4 vertices and 5 edges. All right? Now the example here, for the first one, if you look at something like this, how many vertices are there? 5? 1, 2, 3, 4, 5. 5 vertices, the 5 points. And then 1, 2, 3, 4, 5, 6, 7. 7 edges. And 1, 2, 3, 4. 4 faces. Correct? So 1, 2, 3, 4, 5. 5 vertices. 1, 2, 3, 4, 5, 6, 7. 7 edges. Faces 1, 2, 3, 4. 4 faces. What about this? 1, 2, 3, 4, 5, 6, 7. 7 vertices. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. 1, 2, 3. 3 faces. Whereas with this one, that's only one face, but you've got 1, 2, 3, 4, 5. 5 vertices. 1, 2, 3, 4. 4 edges. Here, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 edges. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 vertices. 1, 2, 3, 4, 5 faces. All right? You need to be able to identify the vertices and edges because eventually you need to use Euler's formula. All right? And that is the only formula that is provided in your formula sheet, I'm pretty sure. All right? So there are not a lot of formulas in your formula sheet, but Euler's formula will be given. I'll teach you what to do a little bit later. Now, sometimes they will use the word network. Again, it's the same. It uses nodes and links. All right? Again, same thing, faces and regions. So make sure that you understand if the question uses nodes, it's actually the same as vertex or vertices. If the question uses links, it's the same as edges. All right? Faces or regions, pretty common for both. So this is for you to be aware of, so that you're not thrown out of if you're not, so that you're not surprised by the question.
Links.
All right. So edges, links, nodes, vertices. All right, let's start off with adjacent and connected vertices. 2 vertices are said to be adjacent if they are opposite ends of the edge. So you can see that in one vertex, the opposite end is A and B. So they are called adjacent. All right? 2 vertices are connected if there exists a path connecting the vertices. So A and C, they are not adjacent, but they are connected because I can go from A to B and B to C. All right? So B and C, because they're connected, they are on opposite end of one vertex or 2 vertices, they are adjacent. Right? A and C are not adjacent, but they're connected because you can go from A to B to C. All right, I'll move on. Next one. Multiple edges. 2 or more edges with which connect the same vertices are called multiple edges. So you can see between A, B, and C, there are multiple edges. There are 3 ways you can travel from A to B. All right? You've got multiple edges between B and C. You can travel 2 ways, B to C. And single edge between A and C. All right? So think about how many edges going in. Anything more than 1 is multiple edges. All right, let's go to the next one. Loop. A loop is an edge that joins a vertex to itself. So a loop starts and ends at the same vertex. So if a vertex has a loop, the vertex is said to be adjacent to itself. So C is adjacent to itself because it has a loop. All right? Now, in this case, C has multiple edges as well. Whereas C to A, there's only single edge between C to A, but A has A to B is single edge, B to C is a single edge. But C itself has got multiple edges. All right, it's got a loop. Now, isolated vertex is a vertex it's not connected to the network, although it's part of the network, but it's not connected. Reese? All right. So you can see that in this graph, this is a disconnected graph. Connected graph means every single vertex must be connected to other. If there's one vertex joining A and D, this is a connected graph. Because there's none between A and D, therefore it's called disconnected or unconnected. Now, vertices are usually labeled with uppercases. Edges are usually labeled using the name of the vertices they are connected to. So for example, this graph has vertices A, B, C, and D. And it has edges AB, AC, that's 1 and 2. Edges AC, BB because there's a loop, and BC, that's 1 edge. All right? There's nothing to D, therefore you cannot describe anything to D. There's no edge to D at all. Now, this is what you need to know because you will definitely need to be able to work out the degree and order of a vertex. So the degree and order of a vertex is determined by the number of edges that touch the vertex. All right? So if a vertex has a loop, the loop edge touches the vertex twice. Right? So the degree is the number of vertices that connects into this, the edges that connects to the vertex. All right, let's have a look.
Bro, you can't give us.
All right, sorry, I forgot. I should write down what A is. How many degrees? The number of edges going into A. So because that's summarized in the next slide. So in A, you've got 1, 2, 3, 4. So the degree is 4. Oops. I've got it there. 4. B, I've got 1, 2, 3, 4, 5 because the loop itself connects in, so that's 5. C, 1, 2, 3, 4, 5, 6. There are 2 edges, there's a loop.
Yeah.
So you consider as 2 going in, so that's 6. And D, 1. And then E, there's none. The order, we need to talk about whether it's even or odd. So that would be even,
Odd.
odd, even, odd, even. All right? Yeah, because I've summarized it on the other page, so I didn't. Yep.
Is when it's like a loop, is that counted as 2 different ones or just one?
2.
Okay.
Loop is counted as 2. Loop is counted as 2. So I've actually done it here. So now the thing that you need to know for this one is the sum of the degrees of the vertex is equals to twice the number of edges for any undirected graph. The word undirected is important. All right? The word undirected is so important because there's no direction. You can go from A to B and B back to A. Alright? I will show you what a directed graph is. Now, I've seen this question appear a couple of times in the exam, also in WAIS exam and in our exam as well, and test. So remember, for an undirected graph, the sum of degrees of the vertices equals to twice the number of edges.
How is that 18?
I'll move on. Next, you can see the example here. Number of edges is 8. Number of degrees is 16. So 16 equals to 2 times 8. Sometimes they will give you the number of degrees of the vertices and the edges, and you'll be expected to draw a graph. Alright? And you can use this. If there's no, if the sum of the degrees of the vertices is twice the number of edges, which means it's an undirected graph. Next. Now, directed and undirected graph. A directed edge or an arc is an edge that has assigned direction. It's like a one-way street, one-way path. So you can see that here, in this diagram here, I can only go from B to A using this path. This one, I can go from B to A and A back to A. This case, A can go to D, that's the direction. A can go to D, D can go back to A. But D cannot go back to A from this direction, from this edge. Here, A can go to C, but C cannot go back to A at all. Alright? So a directed graph or digraph that's used quite common is any graph that involves directed edges. An undirected graph or a non-direct graph is any graph that has no directed edges or arcs. As soon as you see arrows on the edges, it is a directed graph. All right. Now, a directed graph, it can be represented in a couple of ways. So here, you can see that I've represented this one with just one line, which means they are both ways. It can travel from A to B, B to A. Whereas here, I've represented it with two lines, one way going and one way back. All right? So it can be either combined or separate. So basically, the left and the right, they're exactly the same. They're both directed graph, and you can see the direction. So just note that for convenience sake, I always draw a straight line, but really, it doesn't really have to be a straight line. All right? This graph, it could look something like this. It could look, even without this line, it could look with that line coming through. That's fine as well. Now, for a directed graph or digraph, you need to know the in degrees and out degrees. Right? For digraph, an in degree is the number of edges coming into the vertex. Out degree is number of edges going out from the vertex. So in and out. So in this case, go back to the previous one very quickly. There is in, two in, and one out. Even here, you can see that there's two in and one out. So you should know, you should be able to work out the in degree and out degrees. I mean, like today, so I'm just giving you a lot of definition. We'll start looking at some of the problems. How to use all this will be later. All right, now here, if you look at this, vertex A. How many in degrees are there?
2.
In?
2.
Yes, because you've got B to A and C to A, all right? You've got to look at everything. How many out degrees?
3.
3, because A can go to B twice, A can go to D once. All right, oops. So that's 3, and that is 2. What about B? B, you've got 2,
Oh, 2, yeah.
2 in and 2 out. C, how many in?
2.
2 and 1 out. D is 1 in and 1 out. The in is A to D, and then out is D to C. All right? Now, let's have a look at the question. What is the isolated vertex for this?
C.
Pretty straightforward. Which vertex adjacent to A?
E.
E. The loop in the graph connects
B,
which vertex
B.
to itself?
B.
Again, try again. It's B. Yep, correct. Sorry, I didn't hear you. Which pair of vertices is connected by multiple edges? Sorry? E and D, because E and D go down multiple edges. B is multiple edges itself because it's connected by itself. That's a loop.
Yeah.
So B and E. B, E, and D. Alright? Next one. Have a look at this. How many edges are directly connected to Hamilton? Yep, that's 3. GH, GH, and WH, 3. Which towns are adjacent to Melbourne?
Ballarat and Geelong.
Ballarat and Geelong. Ballarat and Geelong. Which town is directly connected to every other? Geelong. Yep. And which town is not directly connected to Ballarat? Warrnambool. Alright? So these are basic examples. You should be able to work your work on the exercises from club today and probably finish in class as well. So I'm going to stop here. Hopefully I've given you enough definition today, and we'll work on a little bit more tomorrow. All right?